Hello everyone. So now we're going to start class 3 of course 1. And this is on TCP dump, IP behavior. So in this class we're going to discuss TCP dump and IP behavior. Let's start with TCP dump. So TCP dump is an open source command line tool for monitoring, that is sniffing, network traffic. And it's a command line tool that we would be using in Linux or Unix OS. And it will give the traffic of the network. So it will give us the packet details. TCP dump works by capturing and displaying packet headers and matching them against a set of criteria. It understands Boolean search operators and can use host names, IP addresses, network names, and protocols as arguments. TCP dump command will work on most flavors of the Unix operating system. And as a command line tool, it will capture and display packet headers, the kinds of requests we are forwarding in a network. Basically, the whole network will be captured by TCP dump on Unix or Linux. Recognizing and understanding. Every location or device on a network must be addressable by using an IP address. Now, this is simply a term that means that it can be reached by referencing its designation under a predefined system of addresses. And that would be the IP address. Each IP address must be unique on its own network, because if you want to communicate between different computers and they have the same IP address, this will become impossible. It will have no way of knowing where to forward the request. So each IP address on a network must be unique. And then an IP address allows network resources to be reached through a network interface. This is all about communication and connecting between the computers and the devices on the network. So next, we're looking at the difference between IPv4 and IPv6. So as we have discussed in earlier classes, we have two kinds of IP protocols. These are two versions of IP protocols, and that is v4 and v6. And they're basically revisions that are widely implemented on systems today. IPv4 is the fourth version of the protocol, and it is currently what the majority of systems supports. However, the world now has too many internet-connected devices for the amount of addresses available through IPv4. A typical IPv4 address looks something below like 192.168.0.5. That's an IPv4 address. Then IPv6 is the sixth version of the IP protocol, and it will look like something below, as you can see here. And so you notice the difference. IPv4 address is a 32-bit value, and IPv6 is the size of 128 bits. So this is why it's important that we start thinking about IPv6, because there are many systems, there are millions of systems that are connected in a network at a single time. And so IPv4 has a limit. It has a 32-bit value. That's why as systems and networks are increasing day by day, we need to create IPv6. So if you want to check if you have IPv4, which is 32-bit, and IPv6, which is 128-bit, you can open your command prompt and type ipconfig in case you're using Windows OS. And then you'll get your IP address. In case you're using Linux or Unix OS, then go to your terminal and type ipconfig and you will get your IP address. And just check it out, which version of IP you guys are using, because it's IPv4 or it's IPv6. In case you're using Linux or Unix OS, then go to your terminal and type ifconfig. Then you will get your IP address. Just check it out. You need to know which version of IP you guys are using, because it's either IPv4 or IPv6. Next is IPv4 address, classes and reserved ranges. So the IP addresses are typically made of two separate components. The first part of the address is used to identify the network that the address is a part of. And that part that comes after this is used to specify a specific host within that network. So to explain, here we are using 192.168.0.5. Now someone either has the IP 192.168.0.6 and 192.168.0.7. So these types of IP addresses will vary within the same network, because the first part of the address is used to identify the network. And so that is the part which is 192.168. Then the part that comes afterward is used to specify the specific host within that network. and it's a specific number. Like from previously, it would be 0.5, 0.5, 0.6, 0.7, and then 0.8, and so on. So where the network specification ends, the host specification begins. This all depends on how the network is configured. So now we're going to look at UDP behavior. So we have two kinds of protocols, as we've discussed, TCP and UDP. And so here we are going to discuss the behavior of UDP. Now the behavior is not specific for UDP, but it is for IP. And unless you have a multicast target, the PC tries to find out the MAC address, the network card, for the IP by doing an ARP, Address Resolution Protocol request, which is in the form of a broadcast. Is anybody there having this IP? So the way UDP works, it works on an ARP protocol. An ARP is Address Resolution Protocol, which converts MAC to IP. And then RARP, that's Reverse Address Resolution Protocol, converts IP to MAC. So UDP works on ARP, and it forwards or broadcasts the packet to simply ask if anybody has a certain IP address. Now the computer which responds, I am at MAC and I have the IP you ask for, gets put into the ARP table whenever the system tries to send something to the IP. So it will send a packet asking if anybody has a certain IP address on that particular system, and then if anyone on that particular system responds that I am at the certain MAC address, it'll give its MAC address, then it'll give the IP. So that gets put in the ARP table, and whenever the system tries to send something to the IP, the next time UDP will work by directly forwarding to a particular system, which is maintained in its ARP table. Next is UDP and TCP. So UDP is a connectionless service, and no session is established between hosts. It does not guarantee or acknowledge delivery or sequence data. However, TCP is a connection-oriented service. A session is established between hosts, and TCP guarantees delivery through the use of acknowledgements and sequence delivery of data. So there's a very simple thing that separates the two. TCP works on a three-way handshake, whereas UDP does not. So the idea of a three-way handshake simply means acknowledgement. So it's just that TCP works through acknowledgement, while UDP does not. UDP is only a broadcast, and it will not work on a three-way handshake. TCP is a connection-oriented service, and UDP is a connectionless service, because UDP has no acknowledgement, while TCP does. Now we're going to look at ICMP behavior. So we've already discussed ICMP briefly, but here we are on ICMP behavior. Host A is sending a packet to host B, and host A's default IP router is router R1. Because host B is a remote host, host A forwards the packet destined for host B to its default router R1. So R1 checks its routing table and finds that the next hop for the route to the network for host B is router R2. If host A and R2 are on the same network that is also directly attached to R1, an ICMP redirect message is sent to host A, informing it that R2 is the better route when sending to host B. The ICMP unreachable message is received in the server to client direction. So it's like you are using a ping command. So what you would do is open your command prompt, open your terminal, and type their ping. And so when you ping their IP address, you will receive some packets. And this request uses the ICMP protocol, the Internet Control Message Protocol. So the ping command will forward a request of ICMP echo. In case somebody is connected on the IP you have requested and is connected to your router, it will show the packets. Otherwise, it will show the unreachable message. ICMP doesn't actually have ports, so you can't actually ping a port. More accurately though, pinging a port is a misnomer. When someone speaks of pinging a port, they are actually referring to using a layer 4 protocol, such as TCP or UDP, to see if a port is open. When someone pings port 80 on a box, that would usually mean that they're sending a TCP SYN to that system in order to see if it's responding. So just remember that the real ping, uses ICMP, which doesn't use ports at all. So now we have finished class 3. Thank you.